Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers Pythagoras Theorem. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Noah is attempting to work out the base of different right-angled triangles. Here is his method for working out y is equal to 10 and x is equal to 6. So he first works out y squared, in this example is 100, then he works out x squared, in this case is 36, then he subtracts one from the other, and then he square roots them. This is basically Pythagoras Theorem, isn't it? So underneath it says tick the correct statement. The method will always give you an answer which is a whole number. The method will sometimes give an answer which is a whole number. The method will never give an answer which is a whole number. Well, his first example here with x and y equals 10 and 6 gave us root 64, and root 64 is 8, so that is a whole number. So that particular example does give a whole number for the base, but if you've ever done any questions with Pythagoras Theorem before, you'll know that that is a rarity. The Pythagorean triples are the ones that give you nice whole numbers, otherwise they are decimals. Now, it asks here that we need to show our working, or show working to support our answer, so we need to give some examples of why we would pick this one. This is obviously the correct solution that sometimes gives us a whole number. But let's give some examples. So when y is 10 and x was 6, we had a triangle that looked like this: 10, 6, and so our base then was going to be root 64, which is 8. But when y, I don't know, we just change one of the values, I suppose. So let's change y to 8 and leave x equal to 6. Then the base is going to be equal to square root of, the square of 8 is 64, so subtract the square root of 6, which is 36, square rooted. 64 subtract 36 is 28, and that is a decimal. And that is a whole number. So just giving an example of where it does happen and where it doesn't happen is enough supporting method to highlight that middle statement there. Question 17. How long is side AB? Now, side AB is the hypotenuse in a right-angled triangle. So we could work it out using Pythagoras Theorem, that this side here then, this side is going to be c squared. C squared equals a squared plus b squared, which is 5 squared plus 8 squared. 5 squared is 25, 8 squared is 64, adding them together, 64, 74, 84, 89, isn't it? So c squared is 89, so c is root 89. which according to my calculator is root 89, is 9.43. 9.43. So, is it between 5 and 8 centimeters? No. Is it 8? No. Is it between 8 and 13? Yes, it is. Is it more than 13? No. Okay, well, we did it a long way there, really, didn't we? I think we could have just said, well, it was between 8 and 13 and just guessed. Can't be less than 8 or 8 or less because it's the longest side, so it's got to be more than 8, and it can't be longer than the two other sides added together because that wouldn't make a triangle. Okay, so that's the other way of doing it. Question 19, here is a right angled triangle and we need to show that x is equal to 12. Okay, so we've got two sides of a right angled triangle and we're wanting to find a third side. So clearly we are dealing here with Pythagoras theorem. Pythagoras theorem states that c squared equals a squared plus b squared, where c is the long side and a and b are the two sides. Okay, so we're just going to sub into there and find what c is and then say that's what x is. So c equals a squared plus b squared. In this case, c is x. X squared is equal to 7.2 squared plus 9.6 squared. So on my calculator, 7.2 squared plus 9.6 squared comes out to be 144. So then x is going to be the root of 144, which is 12. Question 22. I'm given a right angled triangle here, of which I know two sides and one is labelled x, and I'm asked to work out the value of x as a decimal. Okay, so the rule that links three sides of a right angled triangle together is Pythagoras theorem. So I'm going to be using Pythagoras. So using Pythagoras theorem, I know that c squared is equal to a squared plus b squared, where c is the longest side. So that's going to be c, and a and b are my shorter sides. So subbing in those things in, I know that, well, let's just rearrange it first. Do I want to rearrange it first? No, let's sub in. So 8 squared is equal to 3 squared plus x squared. So I want what x squared is. So let's rearrange that. Let's move the 3 squared over. So then x squared is equal to 8 squared minus 3 squared. So what is 8 squared? That's 64, and 3 squared is 9. So x squared is going to be 64 subtract 9. 64 subtract 9 is 55. So then x is going to be the square root of that then. So x equals the square root of 55. Reach for calculator. Root of 55 as a decimal. Work out the value of x as a decimal. Should really round this off. I'm not going to write it all down. Unless otherwise stated, I normally write decimals down to 3 significant figures. So in this case, it would be 7.42. 7.42. What's the units? Centimeters? Question 29. In the diagram, the area of triangle ABD is 56. Work out the length of CD. Okay, in the diagram, triangle ABD. What is triangle ABD? Triangle ABD is ABD. It's this triangle here. And we're told that the area of this one is 56 centimeters. Now, we know that the area of a triangle is half its base times its height. So, area of triangle is half base times height. So, we know that the baseline of this triangle is 14, but we don't know the height. Let's call the height h. Okay, let's call it h. So, then my area of my triangle, which I already know is 56, is going to be a half times my base, which is 14, times my value of h, which I'm actually trying to find. Okay? Right, what can we do with this then? So, half of 14, that's 7, isn't it? So actually what I've got here is 56 equals 7h, and then dividing both sides by 7. Sevens into 56 go 8 times, so that means that h is equal to 8. Okay, so now we know how tall this triangle is. It's 8. Now we want to find the length CD, which is this length here. Okay, now looking at the right triangle, that has got a length of 6 and a height of 8. So I want to know the hypotenuse of that right angle triangle. Now you can do this with Pythagoras Theorem. I already know the answer because I know that 6 and 8 goes with 10. Okay, so I know already that it's 10 because I know what are the Pythagorean triples. Now these are very handy triples to know. So the first one is 3, 4, 5, and then any multiple of that is also a Pythagorean triple. So if you double each of those, you get 6, 8, 10. There's another one, 5, 12, 13. And knowing those means that if you have got a problem that involves Pythagoras Theorem on the non-calculated paper, you can pretty much always work out what these are without even having to think about it. But let's assume you didn't remember the Pythagorean triple. You'd have to use that c squared was equal to a squared plus b squared, wouldn't you? So c squared equals a squared plus b squared, which in this case would be 6 squared and 8 squared. 6 squared is 36, 8 squared is 64. Adding them together, you're going to get c squared is 100, making c equal to 10. So my answer is 10 centimeters, as I already told you. Okay. A square has diameter of 10 centimeters and a square has side length 6 centimeters. Use Pythagoras theorem to show that the square will fit inside the circle without touching the edge of the circle. Now, a square is going to be longest along its diagonal, this distance here. So let's just add that line in. Okay, how long is that diagonal? So that is 6 as well. So using Pythagoras theorem, let's call that d for diagonal. So my d squared is going to be the sum of the squares of the other two sides, 6 squared plus 6 squared, which is 36 plus 36, isn't it? So then d is going to be the square root of 72, which would be very easy to work out if I had a calculator, but this is the non-calculator paper. What we can say though, that we can say that given that 9 squared equals 81, then the square root of 72 must be less than 9. So our diagonal of our square must be less than 9 centimeters in length, and if it's less than 9 centimeters in length, it's easily going to fit inside that circle. So therefore square fits inside circle. The diagram shows a cuboid and its diagonal, and the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem, so when you move from 2 to 3 dimensions, all you got to do is add in your extra length then to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where A is 8, B is 3, and C is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of A squared, 8 squared, plus B squared, 3 squared, plus C squared, 2 squared. So job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So the length is going to be equal to the root of A squared plus B is going to be 2A, so 2A squared, and C is going to be 2A squared, like that. So how many A squareds have we got then? I've got A squared plus 4A squared plus 4A squared, which gives me 9A squared, and the square root of 9A squared, well, the square root of 9 is 3, and the square root of A squared is A. So it gives me 3A. Now obviously when you square root you often get two results, positive and negative, but in this case there is only one solution that's valid, isn't it? It's 3A. Question 15. Sammy is trying to work out the exact value of y using Pythagoras Theorem. So I've got 2y on my hypotenuse there and 6 and 8, don't I? So here's her working. 2y squared is equal to 6 squared plus 8 squared, so 2y squared equals 36 plus 64, so 2y squared is 100, y squared is 100 divided by 2, y squared is 50, y is root 50. What error has she made with her working? Well, I spotted the error straight away. I'm sure you did too. If I've got 2y and I square it, that's going to be 2 squared y squared or 4y squared. Not 2y squared as she's got there. So what error did she make in her working? That 2y squared is 2 squared y squared, which is 4y squared, not 2y squared. Okay, so part B says Kai works out that y is equal to 5. Mel says y cannot be 5 because the hypotenuse should be the longest side and the other sides are longer than 5. Is Mel correct? Well, I think Mel is making a mistake here because the hypotenuse is 2y and not y, which makes 2y would make it 10, wouldn't it? Not 5, and 10 would then be the longest side. So is Mel correct? No, she is not. Give a reason. The hypotenuse is 2y, which would be 10, which would be the longest side. Question 19. Which of these points is not 5 units away from the point 0, 0? Circle your answer. Okay, now some of them are very clearly going to be 5 units away, but the other one's not so clear. So let's have a quick look at this. Let's draw some axes. So the origin is here, look. So minus 5, 0 is going to be here. Okay, and it's pretty clear to see that that is going to be 5 units away from the origin. Similarly, 0, 5. 0, 5 is up here, isn't it? And again, that's going to be clearly 5 units away from the origin. So those two are good. So that one's all right, that one's all right. What about 1, 4? So 1, 4 is 1 along 4 up. It's up there. Okay, so how far is that point? How long is that line? So if we use a triangle like that, then that side of the triangle was 1 and that side of the triangle was 4. And we can use Pythagoras theorem to work out the distance then of the point 1, 4 away from the origin. So using Pythagoras theorem, c squared equals a squared plus b squared, 1 squared plus 4 squared, which is 17, root 17, is c then. Root 17 I don't think is going to be 5, is it? So that is not 5. So that one isn't 5. Let's just double check the other one. 3, 4. So the point 3, 4 is going to be a bit further along. So again, if I draw that point on and then I triangulate it, then that's going to have a triangle which is 3 squared plus 4 squared. And if you know your Pythagorean triples, you'll already know what c is here. But let's just go through the motions in case you don't. 9 plus 16 is 25. So c is the square root of 25, which is 5. So that one's good as well. So the only one that isn't a distance from 5 units away from 0, 0 is that one there, 1, 4. And just a note to self that it's a really good idea to know your Pythagorean triples. It would save you a bit of work. 3, 4, 5, you should already know that that one's going to be 5 away. Okay, so the diagram shows a rectangle inside a semicircle. The rectangle is dimensions 16 centimeters by 6 centimeters, and we need to work out the shaded area. So you can see this shaded area then is half a circle, a semicircle, with that rectangle taken out of it. So finding the area of the rectangle is going to be pretty straightforward. What we need in order to work out the area of the circle is going to be the radius. That's going to be the tricky bit. Okay, so we know the dimensions of the rectangle. It's 6, and from here to here is going to be 16. Now the center of the circle, of which the semicircle is half, is going to be here, isn't it? So that is going to be halfway between there and there. In other words, this half is going to be 8. Okay, now if I draw a radius from here to here, then I can use Pythagoras theorem to then work out what the radius of this circle is. I've got 8 and 6 here, so well, you should recognize that really. This is a Pythagorean triple. So we've got our classic 3, 4, 5 Pythagorean triple. Now this one is double that, it's 6, 8, so it's going to be 10. So the radius of this circle is going to be 10 centimeters. Okay, so now we know that the radius of the circle is fairly straightforward to work out the rest. So, okay, so our shaded area is going to be the area of the semicircle subtract the area of the rectangle. Now, a semicircle is going to have an area of half pi r squared, and the rectangle has area length times width. So subbing in what we know, that's half pi. We worked out that the radius was 10, and the length and width of the rectangle is 16 times 6. So 10 squared is 100, divided by 2 is 50 pi, minus 16 sixes. What's that then? 10 sixes is 60, and 6 sixes are 36, so that's 96. So 50 pi minus 96. Question 16 has a diagram of a lawn, and we are going to be treating it with weed killer. We're told how much area each can of weed killer covers and the cost of each can, and we want to work out the total cost of the weed killer that we have to use. So there are several steps to this problem. The first step is that we're going to have to work out what the area of the garden is in square meters. Once we know what the area is, we can work out how much weed killer we need, and once we've worked out how much weed killer we need, we can work out the cost of that weed killer. So there are 3 steps to this problem. So let's start off with the area of the garden. Now the shape is a trapezium, so we're going to be using the trapezium function, trapezium area formula, which is area equals a half a plus b times h. That's the formula that we need to use. Okay, so subbing in what we know. So half of a and b are your 2 parallel sides that you need to use. So that's a there, and that's b. So it's going to be 12 plus 20 times h. Now h is the distance between your 2 parallel sides. It's that distance. We have a slight problem here in that we haven't been given that length. We've been given this slant height here, that distance. So we need to work out what the height is first. So let's add in another line down here, making a right angle triangle. Now we want to know h, the height. We've got the hypotenuse. What is the length of this baseline of the triangle? Well, this one is 12 and this one is 20, so that one at the bottom there is going to be the difference between the 2, which is 8. Now, if you've memorized your Pythagorean triples, as you should have done, you already know what the height of this triangle is. Otherwise, you're going to have to use Pythagoras Theorem to work it out. So Pythagoras says c squared equals a squared plus b squared. That's the formula we need to remember. But this time we're finding the shorter side, so it needs to be rearranged. B squared equals c squared minus a squared, which is our longer side, 17 squared minus 8 squared. 17 squared is 289 minus 8 squared, which is 64. So 289 subtract 64, 225, and the square root of that is 15. But as I said, you really need to start remembering what your Pythagorean triples are, because they come up all the time in the exams. There are 3 that come up a lot, which is 3, 4, 5, 5, 12, 13, and this one, 8, 15, 17. So you should really remember these 3 Pythagorean triples. It will help you a lot in exams. So they're called Pythagorean triples. But anyway, we now know the height of this triangle. It's 15, so I'm going to put that in there. So now I can work out the area of my trapezium. So half 12 plus 20 times 15 equals half times 32 times 15 is 240. Okay, so the area of grass that we need to treat, we've just worked out, is a half 12 plus 20 lots of 15, which was 240 square meters. Now, 1 can of weed killer covers 90 square meters. We need to use this piece of information next. We've got 240 square meters to treat, so we are going to need 90, 180, 270. We're going to need 3 cans. You can't buy fractional cans from the shop, and they tend to complain, so you need to buy 3 cans. So number of cans required is 240 divided by 90, which is 240 divided by 90 is 3 cans. Just going to write it down like that. Right, so the cost of each can is £19.25. So cost of cans equals 3 times £19.25. Just quickly type that into the calculator. 3 times 19.25, £57.75. Question 16. The area of a right-angled isosceles triangle is 4 centimeters squared. Work out the perimeter of the triangle in centimeters. Give your answer in the form of a plus b root c, where a, b and c are all integers. Okay, so we're given this triangle. We know it's got a right angle in it, and we also know that these two sides must be the same because it's isosceles. Now the area of a triangle is half base times height, so we don't know the height of this or the base, but we know they're the same, so I'm going to call them x. So the area of this triangle is a half base height, which is a half x squared, and that is equal to 4. So what does that make x then? Well, let's cross multiply the 2. So 8 equals x squared, and then we're going to square root to find x. Now I said earlier when you square root you get a plus and minus solution, but in this case a negative solution doesn't make sense because it's a positive length. So we can just use the root x, so the root 8 as the solution here. Okay, so now we know that this side is root 8 and this side is root 8. To find the perimeter we also need to find this side here, the hypotenuse, and we can do that using Pythagoras Theorem. So using Pythagoras Theorem, c squared equals a squared plus b squared. So it's our 2 sides squared. Well, root 8 squared is just 8, so 8 plus 8. So c then is going to be the root of 16. So the square root of 16 is 4, so my longest side there is 4. So then the perimeter of this shape is going to be 4 plus root 8 plus root 8. Perimeter is 4 plus root 8 plus root 8, which is 4 plus 2 root 8. But 8 is a multiple of 4, and 4 is a square number, so I can cancel that down a little bit more yet. So I can say that that's 4 times 2. Breaking that into 2 separate square roots. The square root of 4 is 2, and 2 times 2 is 4. So I can rewrite that as 4 plus 4 root 2. Okay, so it is in the right form now because I've got, this is my A here, look, and then my B is here, and this is my C. So A is 4, B is 4, and C is 2. Question 23. The diagram shows a right angle triangle, which is 4 centimeters along one side and 6 centimeters along its hypotenuse. 4 of these triangles are used to make the shaded square below. Work out the area of the shaded square. Okay. So I think what we need to do is we need to know what the third side of our triangle is. And in order to do that, we need to use Pythagoras Theorem. So if this is side C, A and B, then B squared is going to be C squared minus A squared, which is 6 squared minus 4 squared. 6 squared is 36. 36 minus 16 is 20, so B equals the square root of 20. So that's root 20. So then, how far is it from there to there then? So from here to here we know is 4, because it's the shorter side of my triangle. And so this side here must be root 20 subtract 4. And then so the area of the square is going to be root 20 subtract 4 times itself. So area of square is going to be root 20 subtract 4 squared, because you can times it by itself. So let's just double that bracket out. Root 20 minus 4, root 20 minus 4. So, and do FOIL on it. So root 20 times itself is going to be 20. Then I'm going to have minus 4 root 20 minus 4 root 20. And then minus 4 times itself is plus 16. So 20 plus 16 is 36, and minus 4 root 60, minus 4 root 20 and minus 4 root 20 make minus 8 root 20. Now we need to give our answer in surd form as simply as possible. So can I simplify root 20 any more than it already is? Well, a 20 has got a square factor in it. It's got a 4 in it. So I can rewrite that as 36 minus 8 lots of, well, that's 4 times 5. And the square root of 4 is 2. So I can take 2 out of the surd. So that's going to give me 36 minus 16 lots of root 5. Now I could factorize that as well, but I'm not sure it makes it any more simple than it already is, so I'm going to leave it as it is. So 36 minus 16 root 5. Question 20. All dimensions are in centimeters, and we've got a triangle here, right angle triangle with sides x, 7x and 10y, and we need to use Pythagoras theorem to work out the exact value of x over y. Fun times. Okay, so what does Pythagoras theorem state? Pythagoras theorem says c squared is equal to a squared plus b squared, where c is the longest side and a and b are the other two sides of a right angled triangle. Okay, so here c is 10y, isn't it? And a can be x and b can be 7x. So we're going to sub those values in and see what we get. So 10y squared is equal to x squared plus 7x squared. Okay, so then just removing the brackets, 10y all squared, well that's 100y, x squared is just x squared, and 7x all squared is 49x squared. Oh, sorry, I missed a square off there. So 100y squared is equal to x squared plus 49x squared. In other words, I've got 100y squared is equal to 50x squared. So we want x over y. So let's cross multiply then. Let's divide by 50 and by y squared. And that will give me 100 over 50 is equal to x squared over y squared. Getting close. So 100 over 50 is equal to 2. So 2 is equal to x squared over y squared. But I want to take the square root of this. So x over y then is going to be the square root then of 2. Be the positive and negative square root of 2, won't it? Okay. So work out, well, it can't be the negative one because it doesn't make sense in terms of this problem. So it can only really be the positive solution. So I'm just going to leave it as the positive one actually. So x over y then is root 2. Question 23. The diagram shows the side view of a step ladder with a horizontal strut of length 48 centimeters. The strut is 1/3 of the way up the ladder. The symmetrical cross section of the ladder shows two similar triangles. Okay, and we need to work out h, the height of this ladder. Interesting question. What do we know? Is all the information that is in the question already on the diagram? So it's got a horizontal strut, 48. The strut is 1/3 of the way up the ladder. Now that bit is missing. I'm going to kind of sketch that in, I think. So just going to add a line from there to there. So then the distance from the ground to the ladder there is 1/3. And then this is 2/3, isn't it? So it's 1/3 to 2/3. So that kind of tells us the ratio then of these two similar triangles. Then you've got two similar triangles here, and if they are 1/3 and 2/3, then they're in the ratio of 2 to 3. Then so for every 2 units you've got in the first one, you've got 3 in the second one there. Okay, so we want to basically work out what the length of that line is. Now, I suppose we could add a right angle there if we're dropping it straight down from the top. So then the distance from there to there is half the baseline. Now, if the height of this, if it's in the ratio of 2 to 3, and this distance is 48, if we use that, we can then use that to work out this distance here, the length of this baseline. We can say that, so I'm going to say that the base of my larger triangle is going to be 48 centimeters, which is the kind of the baseline of the smaller of the two triangles, and then I'm going to divide that by 2 and times it by 3, so it's 3 over 2 lots of that then, isn't it? Divide by 2 times by 3. So 48 divided by 2 is 24, times by 3 is 72. So that's going to be 72 centimeters. So then I wanted to halve that, didn't I? So half of 72 is 36. So this distance here must be 36. Okay, so that's 36. And I've got the hypotenuse of the long triangle. So now I can use Pythagoras Theorem to work out the height. I can say that h squared, the height of my pyramid, is going to be 141 squared subtract 36 squared. And that's using Pythagoras, isn't it? So what is 141 squared minus 36 squared? 141 squared minus 36 squared comes out to be 18,585. So then h is going to be the square root of that then, isn't it? So root answer, that's 136.3. Does that look right in my diagram? 136, it's one of the shorter sides, so certainly a little bit less than 141. That looks about right to me. 136.3. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.